People always think we're attacking NASA, and we're actually NASA enthusiasts when it comes right down to it, right? We're space enthusiasts. We want accountability. We want disclosure. We want to see what's actually there, and we will accept the limitation. We'll support the limitations on what's capable of doing. We don't need to keep researching in and find out, oh, all we're looking at is CGI. If you can't do it, say so. These moons are around some of our other planets out there, and they're showing the intensity. Why wouldn't our own moon have that increased, right? And you're looking at it and you realize that that's a logarithmic scale that they're on there, right? The same as vacuum is. When you jump a number, it's a factor of 10.
Yeah, but Earth is the smallest. It would not be millisieverts, 36 sieverts for Io.
But when you're actually farther away from the object, the sun, that is producing this radiation, why do those numbers go to that amount? Obviously, they omitted the moon. Just another one when they're doing the graph. They automatically omit the moon. They don't want to put that in there. It's a whole lot closer than those other moons are around those other planets. It should be higher than that again.
Well, I don't understand why they're showing the moons of Europa and they're not showing the moon of Earth here.
That's right. It's closer to the sun. It should have a higher radiation level. That's my point. The source of the radiation is the sun. These moons that are much further away from the sun have deadly radiation numbers on them. So the closer you get to the radiation, the higher the number should get, which brings us back to our own moon.
It makes no sense at all, that, does it? Not at all.
Somehow are they claiming the source of the radiation is from outside our solar system and that our sun doesn't produce radiation?
Well, there is radiation from outside the solar system.
Yeah, but that chart, the farther you're away from our sun, the higher the radiation gets.
It depends what they're measuring, doesn't it?
The moon's around Jupiter and stuff.
Okay. Certainly, one would expect, if it was just radiation from the sun, you would expect it to be...
It should be increasing in that direction. And cosmic radiation should be fairly evenly spread, flowing through our solar system. Closer to the sun, the radiation should just increase. It doesn't matter which factor or how you decide what kind of radiation numbers you want, right? I mean, I started looking at some of the scales of the radiation that they have, right? So they build a detector that only detects one kind of radiation. Well, that doesn't make sense. They eliminate the cosmic stuff, so of course it won't kill you. If you're only using a radiation detector that will not read cosmic radiation.
Maybe that's what they're doing. Maybe that's what they're trying to show.
It really came to light. I was watching David Attenborough, Planet Earth 2 or something, whatever the series is that he's doing it on there, and talking about flamingos and this high altitude site that they stop at that is so high up this mountainside, this lake that's up this mountainside. When it's warm, it freezes overnight and their feet are being trapped, their legs are being trapped in the ice, right, and have to wait for it to warm up to come out. And he also made the statement, at the height of the elevation, they're very safe there because it's so high up that other predators can't live in that range. And then he made the statement that he said, if you were up there 4 minutes with bare skin and you would be burnt because of the UV radiation coming through at that elevation.
That sequence, I think, was shot in Bolivia at the Altiplano.
And then you realize how fragile we are.
Oh yeah, we're very fragile.
Because that's a radiation burn. That's a UV radiation burn.
That's what sunburn is.
So the exact same thing would happen to you if you're completely outside of the atmosphere.
Yeah, of course it would.
That UV light coming through, because everything coming off, whether it's visible light or non-visible light, is radiation coming through there. When you start to look at it at that level and you realize how fragile we really are, then you have to say, how good are we at space travel? How good is our equipment at space travel? That's when it comes down to the fact we're now seeing the reality. Artemis is showing some reality here. They can't pull a picture back workforce is incredibly stupid. But obviously they can't.
Well, they haven't done it. They haven't showed us that picture yet, have they?
The live stream should be live images from a variety of cameras shooting out, showing us if you turn it around so it's not pointed at the sun, you should be able to see when you're in space. You should be able to see the Milky Way in the most glorious fashion available because we now have the cameras that can capture that. They can be set to capture that. That should be streaming back. We should be able to see that. They're not doing it.
They're not doing very much, are they, at the moment?
And it brings me back to another, is communicating through plasma. Right? You got 10,000 kilometers of plasma in the Van Allen belts. And a CME like that is going to excite that even further. I still come down to space travel as long as you're below the Van Allen belts, like under 400 miles, any of the documents I've read, that they're having trouble communicating above 400 miles off the surface of the Earth. So low Earth orbit, you're going to be able to communicate. So we can have our satellites up there and do whatever the hell they want with them. But when you go through the Van Allen belts, can you really communicate with them? Anything I looked at SETI just said all they listen to is white noise, which is the plasma layer of the Van Allen belts.
Yep.
So if you can't communicate through the Van Allen belts, then you can't send us back an image. You can't communicate back. You can't drive a rover on Mars. And of course, you're not listening to Voyager that launched in '76 with its billionths of a watt, sending the signal back for almost 50 years.
That's quite magical, that, isn't it?
I was reading an article claiming Voyager 2 made alien contact with it and described the encounter. A thing that was sending no more than a beacon, all of a sudden gained all of this capability. It's not just fiction, it is fantasy within the fiction, and that takes it another step further.
It's not reality.
But the reality is you take the X prizes and nobody could even build anything to land. They didn't have to get there. They had to land and deploy a rover. One piece of equipment with the best of the best in the world. There was no launches because they didn't have it, and nobody could complete it in a 10-year period. And that's reality. Could not be done with the best of the best. I mean, all I had to do is pick up the phone and call NASA and say, how the hell did you do it on that asteroid? Just send us the data. How did you catch up to an asteroid that's traveling, I forget how many thousands of miles an hour, and then you landed on another asteroid that's going 14,000 miles around it? There was an asteroid orbiting another asteroid. I saw one article said 75,000 miles an hour, and the other one said 34,000 miles an hour, with the asteroid they landed on going 14,000 miles an hour around it. Well, if you can only get to 26,000 miles an hour, how do you get to even the 34,000 miles an hour to catch up to it?
Good point. I don't know. Ask NASA, they'll tell you.
And then get on to one that's traveling 14,000 miles an hour around it. So they got to stop, line itself up with it, and then do this soft landing. Unbelievable. The entire process and all the documents that they produced doing that should be just classified as fiction. It's a thought that they might like to do it. It's the same as a halo orbit. Anything I've read on a halo orbit, if you're going around a ball, you can't be above it because here we are back at gravity. You're opposing gravity as you're going around, so you automatically are centered to that ball that you're going around. But when you get to physics girl and Veritanism and Curious Droid, they're being taught that gravity isn't a force, so of course you can do it. And they're going to come up with a mathematical theory to show how it's done. What I consider would to be in a halo orbit is they got to go up, turn sideways on the moon, and orbit around the other way so that it's always invisible to the Earth. Then you have constant communication. But now they got to turn it 90 degrees when they get out there. That thing physically has to be on the plane between the Earth and the moon to get into that orbit, and that's the plane you're going to stay on. They have to reverse that and go over the pole this way to get what you would call a halo orbit, right? That takes an awful lot of fuel just to create that and keep it in there, and that's so they now can communicate. And of course, Apollo never had that problem with communications.
No, Apollo did it all the time, 100%. No break in communication at all.
One guy said they never lost a digital packet, long before there was digital anything. they never lost one.
No, they never lost one, because, was it 2 degrees the Earth subtends from the moon? So you've got to keep your high-gain antenna within that 2-degree angle to communicate with Earth. Any movement of it, and it stops.
1 arc second is 200 miles at that distance. And they're using a high-gain, directional high-gain antenna, so-called, to do that. If they're off by 1 arc second, they're 200 miles off course. So they have to be within thousandths of an arc second to be attached.
See, that's probably one of the major problems that NASA will have had. And they thought that they were being very clever by showing all this communication from the moon to Earth, because they had the 3 receivers on Earth in California, in Spain, and in Australia. So they could say, well, we can receive it no matter the position of the Earth. That's not the point. The point is that could the antenna on the moon, assuming it was there, maintain contact? And that's what they couldn't do. So far as I know, there's been not one dropped communication episode during the whole of the Apollo missions where an astronaut is talking or a picture is being shown and suddenly it breaks up. Suddenly it goes out of sequence. Or
the antenna on top of the limb is done manually by hand control. There's a big arm that comes down inside it, and you crank it and pull it up into place and turn it like this with your hand. How the hell are you going to do that?
Well, you're not, because you've got to seal.
There's a whole bunch of stuff missing there. Like, it's right up beside the hatch where this handle is. And he's supposed to turn it in place. First of all, he can't see the Earth or anything. He's inside the craft. And there's no windows up there. And it's manual. Even if you had a really, really, really fine gearing that you could wind around to turn it very gently to put it into place, you could be there for hours trying to line that thing up. And then we go to the rover. Look at that thing.
Yeah, amazing that. Communicate all the time.
And then the other high-gain antenna out on the tripod. It's got some twisty gears on it. They got to get all of these lined up. They don't have enough time for that. I mean, even if they called the guy, it's going to take them a while to get there.
I know, yeah.
Yeah.
But because it all sounds logical and sensible, we believed it just at the time. Oh, no, they've got high-gain antenna. They can communicate with Earth. If you start asking the questions about it, how do you get the antenna lined up on Earth? How do you keep it lined up on Earth? Because the moon is moving, the Earth is rotating, the Earth is also going in its orbit, so you've got the moon and the Earth, which are changing, not very fast, but they've still got to be lined up. And they were on the moon, we're told, for 3 days on Apollo 17. There'd have been quite a change in position. None of that was taken into account. There was no, oh, sorry guys, I've got to go and line up the antenna again. There's none of that.
Like I said, they weren't able to fake it in 1969. They weren't able to fake it. They missed so many things, but they still went ahead and filmed it anyway.
Yes, that's what I mean when I say it was a brilliantly executed propaganda exercise.
And in 1969, it looked really good.
Yeah, it did. It looked very good. It looked very modern, and oh wow, you know, well done NASA, well done America. You know, you got to the moon. Great, well done. You've done what you said you were going to do.
And you see it once on TV, and there's no other resource to see that in unless it's a magazine or an encyclopedia after that. You don't get to see any of the details. You don't get to see the transcript. And today, they had no idea that we could do all of that.
Yeah, and we are doing it. The problem is, so NASA, if you're listening, which I suspect you are, if you're listening, you do have a problem which you've got to overcome. And until you come up front and say, okay, we did fake it, because everybody else knows you faked it. I mean, the Chinese know, the Russians know, the Indians know, Japanese know. Everybody and his mother knows you faked it. So why don't you just come out and say it? Because we want to help. We want to be able to see man in space. We want to see that. Yeah, there are limitations, and we know what they are now. We didn't know back in 1969, 1970. We didn't know that. We know now. We know what the problems are that you have to overcome. Until you do that, until you get honest and say, okay, it was a political event, we had to do it for whatever reason, doesn't matter, we'll accept it. Everybody will accept it. But the continued belief now that we believe what you told us about Apollo 50 years ago, you continue to believe that, you're mistaken.
You can't teach it. That's the problem.
Yeah.
You got to stop teaching it. You got to show where the limitations are and show the reality. Show what the numbers are. It doesn't matter how deadly the radiation numbers are. If the vacuum is such a force that we can only go a few hundred miles off the surface, that's a limitation. But you can't teach these people that because it's already demonstrated, like the X Prize demonstrated the limitations of what you're teaching them. Here's the entire history. You got 50 years of spaceflight behind them, and they can't get off the ground because they don't know how to build it, because they're being taught wrong. If you have to have shielding on all of your electronics to protect it, to keep it in space, even in low Earth orbit, then just come good with that. Now you can teach people how to do it better. But you can't teach them if you say it's not a problem. You say vacuum's not a problem, if radiation's not a problem. All of that stuff isn't a problem, right? Who the hell knows? Like those flamingos. Who the hell knows how those solar panels react when you're outside of the atmosphere?
Yeah.
If that UV radiation is on there. But if you do admit to it, then somebody can design a protective layer that gives that sunlight the energy to power those solar panels without damaging them. They will be able to design a shield. But if you don't tell them that that's going to be a problem, they won't be able to build it for you.
Some of the anti-radiation shielding that's being looked into now is very, very different from what we were told radiation was 50 years ago. Because quite a lot of the technology didn't exist back then. The boron nanotubes. Nobody knew about nanotubes 50 years ago.
That's also bleeding off the ionization of the suit just from the sunlight. So you don't get a static discharge.
Which is helpful.
Well, you do not want to touch a piece of electronics and fry it.
No.
Because you got something closer to a lightning bolt going through you and the machine. Because it will build up without moisture in the air. Like I say, anybody that lives in a climate where it's nice and humid and then it gets cold and very dry in the wintertime and you're just getting static buildup on everything that you've got, right? You have to be careful that you're grounded before you touch something, like don't pet the cat kind of thing, because both he and you will jump at the same time, right?
It's not rocket science, is it?
No, but when you're in space, you have zero moisture. So there's no way to bleed that energy off. And that nanotechnology that's being placed into the suits, they're using that to repel dust sticking to the suit, right?
Yeah.
They're reversing the charge and controlling the charge so that that doesn't happen, that static doesn't build up on the suits as well, right? And hopefully that's making kind of a Faraday cage for the radiation at the same time.
That would help. That would work well. You see, that's the sort of technology that we need to be looking at now. Because if you take what was available with Apollo, none of this existed. It was the luck of Apollo, we're told, that they managed to avoid the radiation. Now people are taking it seriously because there are enough space agencies around. The Chinese, the Japanese, the Indian, the Russian. They all know what the problems are. And they're trying to solve them. And they're making quite considerable advances on it.
When you understand what the problem is, you can educate them and say, we need to resolve this, and they will work on it. But when you take people and you teach them incorrectly, the only thing you end up with is a person like Amy Sherrill and Physics Girl and Veritism and Curious Droid and all of those guys. They're out there just as parrots. And then the other people that listen to those parrots, if they get out on their own or try to do something, or if they send their kids off to school and say, hey, go here. Oh, let's go to MIT. More minions in training because they're not teaching them the right information, and you're just losing years and years and years, and the other countries are going to pull ahead of you. And that's the thing that they have to understand. Their technology, even their electronics, because all of that has to then, if you're going to be in space, has to be protected.
Yep.
And these people are eventually going to come up with something. Maybe they can keep people in space a little bit longer, but the electronics, if they want to be in space electronically with satellites, right, they need to be able to protect them on a long-term type of basis. Every solar mass ejection coming off the sun, is absolutely deadly to everything out there. They can't deal with it. That's a fact. Like when you get a Carrington event that comes up and takes a... In 1989, I don't know if it was considered a Carrington event there where it took out the eastern seaboard of North America, right? That can't happen. So the technology that they might be using in space, they're going to need on the planet in case there's another Carrington event. They need to protect all of the electronics, especially anything to do with banking. I mean, you imagine if money disappeared completely off the planet because it's all electronic and it's all fried.
Yeah, that would be a problem, wouldn't it?
Wouldn't it?
Back to folding money again.
Yeah, but many people would die in the process.
Oh, yeah, they would. Yeah. So next time we get a Carrington-style event, which happened in 1859, that would have basically fried humanity.
Yeah, what, it took down, what, one wire? One telegraph wire?
Yeah.
Because that's all there was, one telegraph wire, so it took it out.
Well, the amount of power going through that one telegraph wire was enough for it to continue working without batteries. That's how much power there was coming in.
Basically, what took in 1989, the energy going into the power lines was feeding back into the power plants, and they couldn't deal with it. The thing they could do is try and turn them off, and that still didn't matter. It was cooking everything. It was cooking all the stations, the lines, and everything else. And I think there was one plant in New York City or whatever, and the guy operating the plant said, I can't shut it down fast enough safely. It's better to maintain it and bring it down and keep it running. And of course, it completely destroyed that plant as that power fed back. He wasn't able to get it offline quick enough, which it wouldn't have made any difference. Didn't matter how he did it.
Yeah, because it would have been absorbing the power from outside, from the radiation anyway. Uncontrollable.
All of this technology that they're looking at for controlling these type of things in space is going to apply commercially here on the planet. Your car's going to have that. Your alternator in your car is going to need that protection. If you're living in a certain area, or if you're living in a northern climate, like even the northern lights zap out snowmobiles, I mean, that take the electronics out. They don't figure out why it's happening. It's just, oh, we're looking at beautiful northern lights, rev your snowmobile up, and all of a sudden it conks out, right? And they're replacing the igniters on them and stuff like that, right?
You know, I think that they will eventually get there. But this is completely unrealistic, what they're talking about. Absolutely unrealistic here.
I would certainly agree with you on that, because where are they going to put it? They say it's going to be a halo orbit.
Oh, they have a small communication device as a halo orbit.
All right, because the only place they can legitimately put it in is at the neutral point, 20,000 miles out from the moon. That's where the gravity of the moon and the gravity of the Earth equalize, 20,000 miles out.
Oh, no, this is going to orbit the moon. The Halo satellite, somebody is going to have to explain to me how you can defy gravity, because when you're orbiting the moon, the gravitational pull, you have to be in center of that ball that you're orbiting. You can't be above it and do a halo orbit. If they're talking about halo where they turn it and it goes around this way so it's always invisible to the Earth, then it's straight. It can be straight on the center of the ball that it's orbiting, right? It has to stay in the center there. Gravitational pull is going to make it stay in the center as it's orbiting around. They would have to go around so that it's visible to the Earth at all times to have constant communications. But when they say halo, halo means above, like over your head. You can't defy gravity like that. But this gateway machine to orbit, the moon, is going to be a manned spacecraft, just like the ISS. It's going to be manned while they're there, and things can be brought up to it, and then the astronauts are going to be brought up to it, get on the lander, go down to the lunar surface, come back up to it, and get back in the other one. Now you've got to have a capsule for the people that are on board manning the gateway computer. You need a couple of other docking ports for unmanned craft to resupply all the time. You need a docking port for the lander itself just to be docked on so they can get on and off the machine. Plus another port for the Artemis or Orion spacecraft, whatever you want to call it, needs a spot to dock to get the astronauts to this gateway machine in the first place, right? That's a hell of a lot of equipment. And the amount of fuel just to land that thing and get back off the lunar surface, because they're only landing 2 people again. The size of the equipment that they're using, it now their design is for a 3-engine descent stage with 6 gigantic fuel tanks. It's unbelievable. I don't know how many launches it's going to take to get all that equipment up there.
I'm sure they'll come up with the answer soon enough, and then we can have a look at their mathematics and their science. Because the idea of having an orbiting space station, which is a reasonable idea to have the gateway station as a sort of staging point, if you're on the lunar surface and you want to get back to the gateway up here, you've got to time your launch to the second, because the gateway is orbiting the moon at, say, 6,000 miles an hour. You're on the lunar surface, stationary, relative to the gateway. You've got to then get from the lunar surface to the gateway, and you've got to time your launch to the nearest tenth of a second to be sure you get it correct. Because if you miss, what are you going to do? Orbit the moon, try again?
With Apollo, the orbiter did the redocking because the ascent module was out of fuel by the time it got up there. Now the ascent module has to have enough fuel to do the docking. They can't be taking that big gateway machine and trying to dock with the little one. The little one's got to dock with the big one. That's another problem.
Which they hadn't even thought of. So NASA, if you're listening to what we're saying here, take note of it and get back to your computers.
They've got to have enough extra fuel on the ascent module to do the maneuver.
And then you look at the comments section. I mean, people are just tearing this apart.
The official NASA one, all the comments were turned off.
Well, of course they were. They've been spotted. They've been found out.
They don't want to see the negativity.
No, because NASA don't realize there are now thousands of people around the world who know enough about space, traveling in space, human activity in space, to be able to call out the problems, which is what they're doing. And NASA are really getting upset. Just after the launch, I discovered last night, NASA told all photographers not to photograph the launch tower. After the Artemis had gone off, after that had happened, photographers had a lot of cameras near to the site. They weren't with the cameras, they were remotely operated cameras, and they weren't allowed to go and retrieve them. The launch tower was so badly damaged that it would be unusable for any future Artemis mission. Now, the launch tower is a problem in itself. It was made by 3 companies who didn't really communicate with each other. So that launch tower, the ML1 it's called, Mobile Launch 1, which launched the Artemis mission, is basically a heap of junk. The excuse given is that we're using technology we don't want other people to know about. That's the excuse. But if the launch tower was so badly damaged it now can't be used for the next Artemis launch, NASA really do have a problem because they can't complete the Artemis program. Now, when the photographers get their cameras back, they're now going to be alerted to the fact that there is something that they weren't supposed to see on the launch. And the reports of bits flying off the Artemis rocket, which shouldn't have been flying off, because don't forget there was a hurricane just before it launched, which damaged some of the covering on it. So NASA really do have a major problem to get sorted out.
Brings into question, did they have enough damage on the machine to continue the trip? Or did they just let it fall into the Atlantic?
That's a possibility.
There's a shot of that machine. That's over 60 feet across, that particular machine. Each one of those tanks is almost the same height as the Apollo lander. Each tank.
It's carrying a lot of fuel.
Okay, this is what Dave did. I made a comment back to him, so he started just going bing, bing, bing underneath the comments. And this is what he said. He claims he's quoting one of the astronauts, the LMP, I've got to get down to the sim bay. 4 hours and 19 minutes in to the flight. I have to get down to the sim bay. Well, you are in the command module. The heat shield is between you and the other part of your capsule that you're in there, right? The sim bay is on the outside. You can't access it from the inside.
No, you can't.
So he pulled this out of the transcript and he put it in quotes, saying that the LMP said, I have to get down to the sim bay. Into the sim bay, which means he's going down inside of it, not as a spacewalk. I didn't go and look this up because there's no way this is in the transcript. You wouldn't believe that that quote would be in the transcript.
No.
Because nobody can go inside that SM. It's full of fuel tanks, oxygen tanks, and electronics, so-called, to run whatever's in that sim bay. The sim bay is only accessed from the outside.
Just so we know what we're talking about, Scott, what does SIM stand for?
SM is service module, is the bay on the outside.
Okay, so it's the big cylindrical bit below the command module. Yep.
And service module. And
Yep.
the heat shield is in between the two. And inside the service module are propellant tanks for the fuel for the engines.
Yep.
There's another oxygen and a hydrogen tank in there to pressurize the systems to push the fuel through.
Yep.
The same as the lander head was the same type of system as that. There's battery packs and electronics to run the switches and stuff in there.
Quite an important piece of kit.
Yes, it is. And that's the one it actually had to do that final burn to get escape velocity to get to the moon. It's the one that brings you into orbit, and it comes back on to take you back to the Earth. It did need a lot of fuel there because, you know, it's downhill all the way, just like Woody Woodpecker said. So it's not a big deal. But Dave is trying to tell me that this is a fact, that the lunar module pilot said, I've got to get down into the sim bay, as a quote, like it was coming from the transcript.
Just ask Dave how he would do that. How the lunar module pilot would get from the command module into the service module. How does he actually do that? He can't go through the heat shield.
And there's no space left in there anyway. It's completely packed full of fuel tanks and everything else.
What was the lunar module pilot saying before he said, I've got to get into the service module? What was he going to go into the service module for?
I think he was going to go in there and take the panel off for the cameras. I don't know.
It's fairy tale stuff, because you can't get from the command module to the service module without doing a spacewalk.
Dave thinks that we don't know anything or haven't studied any of the documentation on this. He's just trying to pull this one over. He needs to go back to his digital photography, and he needs to stop playing around with this, because there's no way he'll ever catch up to us.